All right, today we're going to look at the Pythagorean Theorem. This is 0-8. We've skipped a few sections in chapter 0. You should be pretty comfortable with this. I believe that this one won't be too tough on you, but as always, here are the notes. We're going to walk through it. I'm going to do it in pen. Hopefully this shows up a little bit better on your screen for you right here. All right, Pythagorean Theorem is when we're dealing with right triangles. All right, so we've got to find the 90-degree angle. All right, and we're going to set this up. We're always going to call the hypotenuse C. The hypotenuse is always across from the 90-degree angle. All right, and then we can set this up as A and B. Most of the time in a right triangle, you're going to have a short leg and a long leg. Not always. There's some times that it's not, but most of the time you are. I'm just going to jump right in to example 1. All right, this, obviously in the book, this is page P22, Pythagorean Theorem. If you need that definition, it's in the glossary, or just look up those yellow highlighted terms. Pythagorean Theorem, the equation for that is a squared plus b squared equals c squared. I think most of you probably would have known that, even without me giving that to you right there. So we're going to look at example 1, and we're going to look at part A. They give us a right triangle. And they give us this, that the short leg is 5 inches, the long leg is 12 inches, and they want us to find the hypotenuse. Now notice I am not putting unit measure. If we start in inches, we end in inches. Maybe a little bit sloppy on my part, but you should be able to pick that out, and you should be able to know that. So all we're going to do, just like in any algebraic problem, if we have a formula, we can plug in what we know, and we can solve for what we don't know. So I'm going to plug in 5 for A. I'm going to plug in 12 for B, and we're still going to solve for C. I have seen sometimes in the book, they'll put in X for the unknown. It shouldn't matter either way. We should be fine. So using the Pythagorean Theorem, that becomes 5 squared plus 12 squared equals C squared. Now we're just doing the math. Remember, we're following PEMDAS here. PEMDAS says to do the exponents before we add. So I'm going to do 5 squared, which is 25. If you're not strong with your squares, that's fine. Use the calculator. Then I'm going to add 12 squared, which is 144, and that equals C squared. Pythagorean Theorem says now we need to add these. So 25 and 144 makes 169. If you'll notice, the unknown is on the right side of the equal sign. That's a preference deal. If you wanted to switch this and write C squared equals 169, both of those are saying the same thing. That's on you, and that's up to you. I don't care how you do it. You need to remember how we solve for a variable. When that variable is squared, we take the square root of both sides. Now, technically, when we do that, we get a positive and a negative answer. We will deal with that later on in this class. Right now, I just need to know that the square root of 169 is 13. If you are not good at finding that, then we can get on the calculator. Here's the squared button right here under that's inverse x to the negative 1. X squared is right there. To get to the square root, I hit second. X squared, it pulls up the square root. I put in 169, hit enter, and we get 13. So I know that this hypotenuse right here is 13 inches, and there's my answer. Let's keep going. So in example 1, we're going to do part B. All right, part B, they kind of change the way the triangle's facing. Again, bear with my drawings. They're not always as good as the book, but it's going to be manageable. There's our right angle. Again, we're finding the hypotenuse. I'm coming from this. It says that it's C centimeters. We have 6 centimeters over here. We have 10 centimeters. If we started measuring in centimeters, we're going to end in centimeters when we're dealing with the Pythagorean Theorem. So let's go plug into our equation. The short leg is A, so I'm going to have A squared plus long leg is B. B squared equals C squared. Let's do the math. 6 squared, 36, plus 10 squared is 100. That's going to equal C squared. Pretty simple addition right here. 136 equals C squared. For our intents and purposes right now, when I take the square root of both sides, I am still just going to do it in the calculator. Second x squared pulls up your radical sign. The square root of 136 is 11.66. We need to make sure we're paying attention to the directions. It does not tell us what we're rounding to. So if you wanted, generally, we'll round it 2 places because that's where we round money in real life. But the book rounded it to a tenth. There's really no difference. Let's make sure we're good at rounding to the 10th place. If I'm going to round to the 10th, I need to look at the next spot. If that number is 5 or greater, then I'm going to round this number up. This 6 is greater than 5, so I'm going to go write my answer as C equals 11.7. And again, our answer there is in centimeters. We should be all right with that. Pythagorean Theorem, solving for the hypotenuse, is what we just did. Now, we're going to move to example 2. I'm still on page P22, and we're going to solve for an unknown side that's not the hypotenuse. So we're down here at the bottom. Again, if you can't see it, then either get on your ebook or get one of my class set texts and go to page P22. So the directions say, find the length of the missing leg in each right triangle. I'm sorry, again, this is example 2, part A. So I'm going to draw my triangle. They say that the short leg is 7. This time, they give us the hypotenuse is 25 feet, and I don't know this bottom one. Now, the book calls that long leg A. That's fine. If you know that it's a long leg, I prefer to call it B. It does not matter. So when we do Pythagorean Theorem, here's what matters. As long as I plug in my hypotenuse for C, it really doesn't matter which one of these we solve for. So if you called this A in the book and plugged that in as B, you'd be fine. The way I have it set up, I'm going to plug in the short leg as A and the long leg as B. So that's 7 squared plus B squared equals 25 squared. I've got some math to do. 7 squared is 49 plus B squared equals, if you're not great with 25 squared, no big deal. 25, get the glare off of there. Squared, enter, 625. All right, so it's a good little algebra problem for us. I'm solving for B. Now, when we solve, and I'll teach this as we get into chapter 1 and on, but when I am getting a variable by itself, I do PEMDAS backwards. So I need to get rid of the addition before the exponent, meaning I need to subtract 49 from both sides. And I'm going to get B squared equals, again, 625 minus 49 might not be something at the top of your brain, and that's okay. I can just hit my answer, which was my previous answer was 625 minus 49, and we get 576 is what B squared is equal to right now. Now you know the next step to get B by itself. I'm square rooting, and I'm going to get that B equals second square root of 576, 24. See it right there? B equals 24. I know that's the value of my long leg, and that was in feet. So I don't want to get this question wrong when you see it in a multiple choice setting because of the unit of measure. Not a big deal, just pay attention to that. All right, let's do one more. I'll slide it over. We're going to do example 2B, and we're going to call this someday. Pardon me.
Teacher, please excuse this interruption. Any student whose last name begins with K through O that doesn't have the computer yet needs to report to the Mac Shack at this time. Thank you.
Ignore those announcements. We're going to keep on keeping on. All right. So they give us our right angle. They give us the hypotenuse up here is 4. It's in meters this time. All right. We have a leg, which I believe is my short leg is 2, and we're going to solve for the long leg. So pretty similar setup to the last one, just a different looking triangle. No big deal. A squared plus B squared equals C squared. Plug in what you know. Solve for what you don't. 2 squared is 4. I don't know B squared. Again, side note, some people might be plugging in X for the unknown. That's fine. Just make sure you know that you're setting this up right. Namely, put in the hypotenuse is C, and everything else algebraically will be okay. 4 squared is 16. Minus 4 from both sides. I get B squared equals 12. First of all, that's not a perfect square. We will get to where we reduce radicals at some point in this class. That's not today. So I'm going to go to the calculator. All right. I'm going to do second square root of 12. We again see that we've got a nice nasty decimal here. I'm going to round to this first place like we did a couple examples ago. So if I'm rounding to the 10th, I need to look at the next place. If that's 5 or greater, we round up. It is. So we're going to say that B equals 3.5. And again, the answer was in meters. One thing you might see, just from a notation standpoint, is somebody might put B and they'll put little squiggly lines and put 3.5. This is just saying, hey, our answer is approximately 3.5 because it's not exactly 3.5. You can tell by this decimal. So if you see this, I'm not necessarily going to expect that from you right now, but that's something that you might see, and I want you to have a good understanding of what's happening. Pythagorean Theorem, I really believe is stuff that you're going to be good at, and you're probably already really good at, and that's good. Continue to be good at it, and make sure that we're getting through this. If you have questions, raise your hand or come see me, and let's get it figured out. Thank you.